let's go ahead and work a problem. So for whatever reason, I have gotten in the habit of, when I do gas law problems, I write a little box with my gas in it, and I write the pressure, volume, number of moles, and temperature over to the side here. And then I go ahead and go up to my problem, and I take what the value is and I put it down there under my 4 variables. Keep in mind that PV is equal to nRT. So remember your final exam, you can bring a full sheet with you, and you might want to go ahead and put that equation on there because you're going to have one of these probably as a multiple choice question to knock out. So let's see, what is the gas pressure? Okay, so I'm going to find what is the gas pressure. Pressure question mark. Inside 750 with 3 sig figs milliliter flask. So that's volume, right? So volume, I'm going to put 750 decimal milliliters. That contains 0.0284 moles, so that's my N, 0.0284 moles of gas at a temperature of 22.0 degrees Celsius. Now, just a few things off the bat. Well, first off, remember we have a value for R. That was the one I gave you on the previous slide. And let's see, we have... Let's see, volume, we have number of moles, we have temperature. Do you see where the only thing I don't know is pressure? So we are in good shape to go ahead and solve this for pressure. Another thing though, remember, what units does volume have to be in? Volume needs to be in units of liters. What units does temperature need to be in? Temperature needs to be in units of Kelvin. So here on the next few slides, I'm going to, fix those two quantities so that they're in the right units. Okay. So yeah, like I said, this is the ideal gas law constant. And you're probably going to want to jot this on your sheet somewhere too. So the units of the value of R that we're using anyway sets the units for our pressure, volume, number of moles, and temperature. Well, number of moles and temperature is obvious, mole and Kelvin. So the amount of gas needs to be in moles, temperature needs to be in units of Kelvin, which we got to fix, right? Because they're given Celsius, we got to get them to Kelvin. The volume in this case is given milliliters, we got to get it to liters, okay? And then in that case, the units of pressure will be units of atmospheres. Dun, dun, dun. Okay. So a good way, I think, to handle this is to rearrange the ideal gas law constant for the variable you're trying to solve for. So we're trying to get to pressure, and notice if we can isolate pressure by itself if we divide both sides by volume. Does that work for you? So pressure is equal to nRT. So here we go. We're going to go ahead and substitute in our quantities. So we said that the number of moles, 0.0284 moles. R, of course, is number of moles is 0.0284, yeah. The ideal gas law constant, 0.082058 units of R are liters atmospheres per mole Kelvin. Now the temperature was given in degrees Celsius, and we covered this before. If you want Kelvin from degrees Celsius, you have to add 273. In this case, 0.15 will be the route to go. So you go ahead and your rounding isn't, anyway, 27.315. Round to 1 decimal, you get 295.2 Kelvin. The other thing, volume, we're going to have to fix volume because it's given in milliliters. Don't simply move the decimal place over 3 places to get from milliliters to liters. Use factor label. We've been using that later. So how can we go ahead and convert this into liters? We'll put milliliters on the bottom, liters on the top. Looks pretty good to me. So that means we have 0.750 liters. So don't forget that trailing 0 after the decimal gives you 3 sig figs. So now we're going to plug and chug. We're going to put this N in here. We're going to put this R right here. We're going to put this T right here. And give me a V. We're going to put this V right there. Okay. And it looks like this. There's N, R, T. Notice that I'm bringing all of the units along. And V. So let's see what units cancel. So moles cancel with moles, Kelvin cancel with Kelvin, and here liters in the numerator cancel with liters in the denominator. We're left with units of atmospheres, which is perfect for pressure. So how many sig figs are we allowed in our answer? I'm liking 3 because we have 3 here. We have actually 1, 2, 3, 4, 5 here, but we're always conservative, go with the fewest. We have what? 4 here, and we have 3 here. All semester long, we've used the same rules for rounding. So here we go. Did you get 0.917 atmospheres? So that is the pressure of the gas given those number of moles, temperature, and volume. Now notice that we didn't care what the gas was. It could have been any gas. But if it's behaving ideally with the number of moles, temperature, and volume, its pressure is going to be 0.917 atmospheres.